We often wonder why pressure reduces when there is a reduction in cross section area of the pipe. Let us discuss how it is and why it is. So in this section of the pipe there is a velocity V1 and pressure P1 coming from this side. As per the mass conservation, the velocity in the smaller cross section must increases, but at the same time it increases at the cost of pressure. But we cannot get the feel that there is a much higher velocity why we are having a low pressure, and if we are standing here why we are feeling more pressure and getting the feel that the pressure should be more here in this section. So we all know that pressure and velocity means the speed is constant in this section as well as in this section, and the speed is more in this section because of the less cross section. So the fluid coming in this side has to accommodate in this pipe as per the volume, so it should get faster rate at which it is going out, because the mass fluid coming from this side is constant, so the continuous mass is coming from this side. Now to get the feeling of the pressure that P1 is more than P2, we have to consider the energy conservation. So in this section there is a energy E1 which is having a two parts, the pressure energy and velocity energy. Similarly in this section there is a pressure P2 energy and velocity energy, and in all the three sections as per the energy conservation law the energy E1, E2 and E3 all should be same. But still we didn't get the idea that why the pressure in the P1 section is more than P2 in the small section. To understand this we have to imagine two scenarios. So let us consider the first case where you are standing in the pipe at two different locations one after the other, and the second scenario where you are moving inside the pipe with the velocity same as the velocity of the fluid. So in the first scenario you are standing here and you are not moving, so whatever the flow is coming in from this direction you are feeling the pressure P1 which is due to the fluid with the velocity V1 due to the momentum transfer from the fluid to your body. So you will be feeling total energy E1, which often we call as a stagnation energy or stagnation pressure you are feeling here, which is due to P1 and V1. And we all know that E1 and E2 are equal in both this section, because you are also feeling pressure P2 and the velocity V2 in this section. So here you are standing, you are not moving, and the velocity of the fluid directly coming to your body and impacting. So you are feeling the pressure and velocity, and it doesn't matter it is V1 or P1 or V2 or P2, you are feeling the total energy which is here and which is equal to the E2 energy which is here. So in this scenario where you are blocking the fluid, you are blocking it completely, you are feeling the stagnation pressure, and the stagnation pressure in both the section P01 and P02 both are equal because it is of pressure energy and velocity energy. Though the velocity and pressure energies are in both these sections are different, but you are feeling a sum of the energy, and in fact the pressure energy is converting to the velocity energy in this cross section. But we still didn't get the idea why the P1 is more than P2 in this section. We are feeling the same pressure energy in both the section, which is not same as the pressure energy, but it's a stagnation energy. Now the velocity V1 is greater than V2, which we all know that due to the cross section it is coming out faster. So you are feeling the fluid faster here, but the pressure P2 is less in this section, so you are feeling the more P2 pressure here, P02 pressure, which is more than P1. So let us consider another scenario so to get the clear idea. Now let us consider that you are moving with the fluid with the velocity V1 in this section. So you will be feeling from all the side pressure P1, and in this scenario you will be feeling the pressure from all the side due to P1 plus the velocity of impact from this side. Now In this cross section you will be feeling pressure P1 because you are also moving with the velocity of the fluid, which is V1. In this section you will be feeling pressure P2 because you are moving faster, because your velocity is now V2, you are moving with the fluid, so you are not standing in these sections, you are not feeling the stagnation pressure. The stagnation pressure is more than the static pressures. Static means you are moving with the fluid and you are feeling the pressure on your body from all the sides. Now, in conclusion, we can discuss three scenarios. The first scenario, the P02, which is in this section, stagnation. Of course, it is more than P2 because you are here moving, you are not feeling the velocity. So in P02, it's both the component V2 and P2, velocity energy and pressure energy, which is of course more than P2. This pressure energy, of course, the stagnation energy is more. You are feeling the velocity of the fluid, and we all know that P01 and P02 is same, as the stagnation energy is the total energy in both the cross sections. So the second scenario, that P01, of course it is more than P1 because the P01 stagnation energy is the total energy of V1 and P1 in this cross section. In this cross section you are feeling it here, and the pressure P1 you are feeling in this section because you are moving with V1. Now, so after combining these two criteria, we can conclude that P02, it is greater than P1 because P02 and P01 are same. So P1, which is in this section, in this first section, the P01 is less than P02. So we can get the idea that when we say that in this section we are feeling more pressure, it is not actually the P2. You are feeling the pressure which is P02. Okay, so to get the feeling that P2 is less than P1, you have to move with the faster velocity. And in fact, if we compare the pressure, we have to compare it as with the stagnation pressure. So you are right that pressure in this section is more. You get the feeling that pressure in this section will be more if you are considering the stagnation pressure in this section, which is P02, which encompasses the both V2 and P2. But this V2, you are not feeling V2 until you are moving with the velocity V2 in this section, which is of course less than the P1. And to get more idea, you can use the Bernoulli's equation and the conservation of energy equation, and you can imagine yourself in these scenarios, and you can get the feeling that of course the P2 is less than P1. Thank you all. Please subscribe the channel so that you can get more insight videos like this and clear your concepts which are quite counterintuitive to some people, and suggest some ideas to get more videos like this in the comment section. Thank you guys.